2 more questions. A rectangle has these vertices. Show that the diagonals of the rectangle bisect each other. Okay, so I'm going to start with a quick little sketch so we can orient where these lines look like they're going to cross. So E is -7, -3, so it's down in quadrant 3. F is -721, so it's up here, directly above. G is 321, and H is at 3, -3. So it's looking pretty rectangular with that quick little sketch. So this was E, F, G, and H. It's important to draw a little sketch, or at least sketch it in your mind so that you know which ones are diagonal from each other, because if you start finding diagonals between two that are actually adjacent to each other, the whole thing's going to fall apart. So we need to prove that they bisect each other, which means that if I draw a line here from F to G and I cut it in half, so let's say here's the middle, so this and this are equal to each other, and then I draw another line F to H and cut this in half, this midpoint of the blue one, EG, should be the same midpoint as FH. If they don't bisect each other, you'll end up with something like this, and the middle of this one might be here, and the middle of this one might be here, and they're not the same as each other, and therefore they don't bisect. Bisect means they cut each other in half. So okay, so we need to find the midpoint of both of these diagonals and just prove that they are in fact the same or they're not. So the midpoint of FH, let's start with that one. Sorry, the pen is going super weird right now. I think I've written too much today. Wants a restart, but that's okay. Midpoint formula, again, like always, write down your formulas. I'm not, just for lack of space. All right, so FH, -7 plus 3 divided by 21 plus -3. Whoops, I don't know what I'm doing here. It's been a long day. That should have been divided by 2. -7 plus 3 divided by 2, comma, 21 plus -3 divided by 2. -4 plus 3 is, -7 plus 3 is -4 divided by 2 is -2. 21 minus 3 is 18 divided by 2 is 9. So the midpoint of FH is at -2, 9. Now we'll check and see if it's the same midpoint EG or not. E and G, -7 plus 3 over 2, that's looking familiar. And -3 plus 21 over 2, also looking familiar. So we get -2, 9, which means that if these two midpoints are the same, which they are, then these diagonals bisect each other. So therefore, wow, okay. You know what I mean. Therefore, the diagonals bisect each other. It is not liking my writing right now. All right, last question. So we have quadrilateral ABCD. We are given the coordinates of all 4 vertices. Determine what type of quadrilateral it is. So we need to look at the lengths of the sides to say whether it's a rectangle perhaps, or a square, a rhombus, a parallelogram, a trapezoid, or a kite, or just some random quadrilateral. So if the two sides that are opposite to each other are the same length and the other two are also the same length, it could be, a rectangle or a parallelogram or a square or a rhombus. If you find that two sides that are opposite to each other are not the same length, then that will rule out the square, the rectangle, the rhombus, and the parallelogram. So all you will be left with is either a kite or a trapezoid, and then you have to do some more work from there. So lengths is the first part. So you need the distance formula, the length of a line segment. The other thing you need to look at is the slopes. If it's a square or a rectangle, it's going to have some sides that meet at 90 degrees. So the slopes will be perpendicular to each other. So you have to determine first side lengths and second slopes, and then based on whatever results you get, you have to rule out some of the quadrilaterals that we know, and then figure out from there what other information you need. So let's start with some lengths. Actually, let's start with a little sketch. That will help as well. So we have our XY axes. A is at 1, 7. B is at -5, -5. C is at -2, -11. And D is at 7, 7. So it's looking possibly like a trapezoid. Those two sides, AB and CD, might be parallel to each other. It's hard to say for sure without doing the math. So we need to see if they're the same length or not. Maybe my drawing sucks. Maybe this is actually a rectangle. I can't tell. So let's start with the lengths. So we'll look at the length of AB. So -5 minus 1 is -6 plus -12 squared. So that's the square root of 36 plus 144. I'm just going to leave it as the square root of 180. If we need the decimals, we can worry about that later. And then I'm going to find the length of CD, because that side is directly across. And if they're the same, then it could be a rectangle or a parallelogram, a square, a rhombus, something like that. If they're different, then we can rule out those four and look at trapezoids and kites. -2 minus 7 is -9. All squared will be 81. Oh, and there's the dead spot. So that's 81. And -1 minus -7. Hold on. I think I wrote that wrong. I don't know what I was doing there. Okay, let's start this again. C and D, -11 minus 7 squared. Wow. Okay, -11 minus 7 is 18 squared is 324. Anyway, and this is the square root of 532,405. So these are definitely not the same length, which means it's not a square, a rectangle, a rhombus, or a parallelogram. So we can rule those out, and all we're left with is it's either a kite or a trapezoid. So I'm going to start looking at the slopes, because if it's a trapezoid, these sides would have to be parallel to each other here and here. If it's a kite, they will not be parallel to each other. So I can either say it is a trapezoid or rule out a trapezoid. And if I say it's not a trapezoid, then I can determine whether it is a kite or not. I'll have to look at the other sides and see if AD and AB, for example, are the same, and then BC and CD, or vice versa. Okay, so the slope of AB -12 over -6, so 12 over 6 will give us 2. And the slope of CD negative 18 over negative 9, which will also give us 2. So these slopes are the same. So because these are different side lengths, and because the slopes are the same, this is in fact a trapezoid. The quadrilateral is a trapezoid. So like I said, if let's say we got 2 and then let's say 3 for the slope, or negative anything, it doesn't really matter. If the two sides that are across from each other, so AB and CD, they're not the same length, we can rule out rectangle, parallelogram, rhombus, and square. So we're only left with kite or trapezoid, or just a random quadrilateral that doesn't have a name. Then we look at the slopes of these two. They happen to be the same, which means it's a trapezoid. It doesn't matter what the length of A, D, and B, C are if it's a trapezoid. We've already ruled out that it's, not a rectangle or a parallelogram, so it has to be a trapezoid if these two are parallel. So it's a trapezoid. If we ended up with them not being parallel, if we got two different ones, then we'd have to look at AD and BC and determine if it's a kite or not. And at that point, you could say it's either a kite or it's just a quadrilateral that doesn't really have a name.